Okay. What is going on? Okay, do we have any questions over 2-4? The answers are on the sideboard over there. Do we have any questions over 2-4? Yes. 15. -3 plus I square root of 2. Okay, the directions say write the complex conjugate of the complex number, then multiply the number by its complex conjugate. So my first question is -3 plus I square root of 2 simplified? In other words, is it a complex number with an I on the outside and there's no negatives underneath the radical? It is. So I'm immediately going to put parentheses around this, and then I'm going to multiply it by its conjugate. What is the conjugate of -3 plus I square root of 2? -3 minus I square root of 2. And since we know that these two items are complex conjugates, all you have to do is when you FOIL them, you are simply going to do the first terms. -3 times -3 is +9. And the last terms, -I squared square root of 4. So this right here is going to come out as a 2. And that's going to change that to make that a +2. Do you see that? Because I squared is -1. So the -1 times the negative makes that a +2. And this is going to give you 11. Do we understand number 15? Any other questions over section 2-4? 16. 16 is kind of a fun problem. This is the square root of -20. Now, the directions say to find the complex conjugate of that. Well, I can't find the complex conjugate of that until I first simplify this. So how do I simplify the square root of -20? Well, the way I'm going to do that is by simply writing this as I squared times 4 times 5. Why I squared? Because I squared equals -1. 4 is the perfect square. So this comes out as an I. This comes out as a 2 to give you 2I square roots of 5. Now, here's my question to you. That is a complex number, where the real number is 0, and the complex, the imaginary part of it, is 2I square roots of 5. So what is the conjugate of that? The conjugate of that is going to be the opposite of 2I square root of 5, making that minus 2I square roots of 5. Do we understand that, yes or no? So when you multiply this together, you get -4I squared, square root of 25. This comes out as a 5. This turns into a -1. So I'm going to have -4 times -1, which is +4, times 5, which is 20. Do we understand number 16? Are we good? Do we have any other questions over 2-4? Do you not like this problem stuff? Okay.
For the 90 thing, we added that. Why in 16 do we multiply 4 and 5?
Okay. This one right here, this is going to be 9 minus a -1 times 2. Because the square root of 4 was 2, and I squared is -1. Yes? So this is going to be 9 plus a 2, because this right here turns into -2, and a double negative creates a positive. So that's why I get 11. Does that make sense? Not do it on 16?
Yeah.
Okay, because on 16, this right here is the square root of -20. So I have to get the 2I square root of 5. So do you understand that -20 is the same thing as 2I square root of 5? Do you get that? Okay, this right here is 0 plus 2I square root of 5. Do you understand that? Like if I put this as a complex number, where it's a plus bi, a is the real part, which is the rational number, which is 0. And this is the imaginary part, which is 2I times the square root of 5. So the conjugate of that has to be 0 minus 2I square root of 5. Does that make sense? because the imaginary part is the only part that changes sign. So that's the conjugate. So if you were to multiply those together now, I'd have 0 plus 2i square root of 5 times 0 minus 2i square root of 5. First term gives me 0. Last term gives me 4i squared square root of 25, which is exactly what we have over here. Does that make sense? Okay, so that's why that 0 is not relevant there. And this right here is going to make that a positive 4, and the square root of 25 is going to be 5 to give you the 20. Does that make more sense? You don't like it still. I get it. Okay, what is the biggest thing that bothers you in this problem? Like this calculation right here? Okay, because 9 this right here is the rational part. This is the imaginary part. You with me? Whenever I calculate the imaginary part over here, that imaginary part is going to be -1 times 2, which is going to give me the 9 plus the 2. My real part, which is my rational part, is the 0. My imaginary part is what I calculated, and that's why I multiplied 4 times 5. That's the same thing as multiplying -1 times 2. That's the imaginary calculation. This right here is the imaginary calculation. I multiplied -1 times 2 to get the -2. So what I would have is 9 minus -2. So this was the imaginary part that I'm adding, and I multiplied that together. I multiplied the -1 times the 2. And this is the imaginary part that I'm calculating over on this side as well, which is why I'm multiplying 4 times 5. Because I'm simplifying the imaginary part of the complex number. You with me? Does that make more sense to you now? Awesome. Okay. Thank you for continuing to ask me to understand. I appreciate it. Okay. Number 9. Okay. Number 9, on the same worksheet, yes? So I have the square root of -6 times the square root of -2. When we calculate this, we have to get rid of that negative underneath the radical. So that's going to make that a I squared times 6 times I squared times 2. So that's I square root of 6 times I square root of 2. Do you understand that part? Now multiply the i's on the outside to give you an I squared, and then multiply the 6 and the 2 together to give you a 12. So I squared is -1, and this is going to be 4 times 3. That comes out as a 2 to give you -2 square roots of 3. Do you understand where you messed up? Okay, turn 2-4 over. Or do we have another issue? Number 1's even easier. So what's A? If I have A plus BI, what is A if I'm looking on the right-hand side? What number's in the A position? You with me? Does that make sense? It's so simple that you're like, oh. We good? Okay, now turn it over. Any questions on the back of 2-4? I'm sorry? 27. 27. So this is this parenthesis, the square root of -2 to the 6th power. Okay, I have to simplify the inside first before I can do anything with that. So this is going to be I squared times 2 to the 6th power. So that's going to be I square root of 2 to the 6th power. Do we see that, yes or no? So this is going to give me I to the 6th times 2 to the 1/2 times 6. Do you see that? So that's going to give me I to the 6th times 3 to the cube. Yes? Power over root? Does everybody understand that? 2 times 2 times 2 gives me 8. I to the 6th. Now, how do I break down I to the 6th? Well, that's going to be the same thing as I squared cubed. So that's going to be 8 times negative 1 cubed, which is simply going to be negative 8. Yes? What do you not like? Do you understand this step?
Yes.
Do we understand this step?
Yes.
Do you understand what I did here?
I need to use it minus 6. What is the square root of 1/2 6?
Power is 1, root is 2, so I got rid of the radical and wrote it as a fractional exponent. Then I'm multiplying those exponents. Half times 6 is going to give me a 2 cubed. 2 cubed is going to give me 8. Yes. Yes, because the power on the inside, on the 2 is a 1. You don't see it, but it's understood to be a 1. And the root, the radicand on the inside of this root is a 2. So that's a square root. You don't see it, but you know that it's a 2. Because all the other numbers would be cube root. You would see the 3, you would see the 4, you would see the 6. You with me? So that's going to make that 1 over 2, and I'm going to multiply those exponents to give me 2 cubed. If you don't like it like that, this is going to give me 2, this is going to give me 2, and this is going to give me 2 to give me 8. If you have to write it out like that, write it out like that. Whatever makes your brain work. You with me? Okay. My brain thinks I'm not writing all that out. I'm going to make this into a fractional exponent, multiply those exponents to reduce it, and then I'm done. Okay? Any other questions on the back side of 2-4? Okay. How about 2-3 worksheet 1? Number 8 on 2-3 worksheet 1. Okay, f of x is equal to x cubed plus 2x squared minus 5x minus 4, and my k value is negative square roots of 5. Now, here's the beautiful thing about radicals. Radicals come in pairs just like a plus bi. So if the square root of 5 is a root, then my positive square root of 5 will be a root. But that's not what the problem's asking for. The problem's asking you to do synthetic division at this value. So I'm going to go ahead and put negative square root of 5 inside the box. Now I'm going to go ahead and bring down the coefficients. 1x cubed, 2x squared, minus 5, minus 4. And I'm going to leave some space. And the reason why I'm leaving some space is because that's a square root, right? And whenever we're dealing with square roots and we have to multiply, we're probably going to have a rational and an irrational part of that root. Okay? So if I go ahead and I drop down the 1, this is going to be negative square roots of 5 here. So that is going to give me this. Do we see that? Yes or no? So if I add this, what I'm going to do is I'm going to have negative square root of 5 times 2 minus the square root of 5. And that's going to give me negative 2 square roots of 5 plus the square root of 25, which comes out as a 5, to give me 5 minus 2 square roots of 5. Does everybody understand what I did there? Yes? Okay, so that's what's going to go here. The 5's cancel out, I'm left with negative 2 square roots of 5. So I'm going to come back over here, and I'm going to take negative square root of 5 times negative 2 square roots of 5. So that's going to give me a positive 2 square roots of 25, which is going to come out as a 5, which gives me a 10. Yes? So 10 goes here, and that's going to give me a 6 as my remainder, which means if that is my remainder, I have to write this as factors. So that's going to be x. Then this is minus square root of 5, so this is going to be plus the square root of 5 because I'm bringing it on the same side as x. This now becomes degree 2 because it was degree 3. So that's going to be an x squared plus, put parenthesis, minus 2 minus the square root of 5 times x minus 2 square roots of 5 plus my remainder of 6. Did we see that? Yay or nay? It's kind of nasty. Okay, it is kind of ugly. But I did number 7 for you yesterday, and today I did number 8 for you. So be ready. You're going to have a square root like that on the test. You need to make sure that you know how to do those. So make sure you practice that because I've done both of those for you guys in class, okay? Be certain you practice that. Okay? Turn it over. Any other questions on the back? How about I give you the answers? 9a, f at negative 2 is 14. 9b, f at negative 1 is 2. 10a, g at 1/3 is negative 5 over 3. And 10b, g at negative 5 is going to be negative 199. Are we good on 9 and 10? Did you get them all right except for that one? Go back and check it because I guarantee you know what you're doing. You just have the calculation error. Problems 11 through 14. It says use synthetic division to show that x is the solution of the third degree polynomial equation and use the result to factor the polynomial completely. So if you factor number 11 completely, you should have x minus 2 times x plus 3 times x minus 1. Did we get that? Number 12, it should have been x minus 2 times x plus 6 times x minus 4. Did we get that? No, it does not. Good question. It does not matter if you put the x plus 6 first or last or in the middle, okay? Just as long as you have them all attached by multiplication somewhere together as a binomial. Number 13 is x minus 2, x minus a half, or you could have written that as 2x minus 1, and times it by x minus 5. And then number 14 is going to be x minus 2/3 times x minus 3/4 times x minus 1/4. And again, you could have put the denominators over with the x if you wanted to. Yes? Any questions over 11 through 14? Do you feel like you understand that? So overall, you guys did pretty well on 2-3 worksheet 1. Would you agree? Excellent job. Super proud of you guys. Okay, the last worksheet. This was a bit harder, wasn't it? It was a challenge. It was a challenge. So number 1, the zeros that you should have gotten were x equals negative 2, positive 1, and 1/2. Did you guys get those? You did not. You should not have put 1 twice because your last polynomial when you did synthetic division should have been 2x minus 1. Circle that one and come back to it. If we have time, we'll do that one, okay? I didn't. It's degree 3. So you should only have 3 parentheses. You with me? Well, you never should have had one once. Because once you do synthetic division, you have to do synthetic division again from here. You factored it. They gave you 2 roots. You only had to do synthetic division twice, just like you did here. You with me? And then that would have brought it down to degree 1, and then you'd have to 2x minus 1. See what I did? Make sense? Okay, now, number 2 we did in class. Number 3. It should have been x is equal to negative 1/2, 2/3, and negative 7. Yeah? Number 4, you should have had x equals 1/2, square root of 5, and negative square root of 5. Okay, if you didn't get them, circle them so you know you need to go back over that one. Okay, number 5. What did you get for your total P over Q list? So this is the third line that I want to know. P over Q. You should have gotten plus or minus 1, 3. Did we get that? So what is your viewing window? Negative 4 to 4. Number 6. This was a big one, wasn't it? You should have had plus or minus 1, 3, 5, 9, 15, 45. Then 1/2, 3 over 2, 5 over 2, 9 over 2, 15 over 2, and 45 over 2. Why do you have those other ones all divided by 2? Because your Q value is 2. So it's plus or minus 1 and plus or minus 2 is what you'd have to be dividing each one of those by. So what would be your viewing window for that one? Absolutely. On the test, each one of those P over Q values is a point. Do we all understand that? Okay, number 7, positive sign changes. Sign changes in f of x. How many do you have? 3 or 1? right? So I need you to make sure that you know you're subtracting 2 every time. So what about f at negative x? 1. So your chart for number 7 should be what? Going across 3, 1, 0, 4, and the next one is 1, 1, 2, 4. Yes? How do we do? 1, 1, 2, 4. Okay, what about number 8? Number 8, what did you get? How many positive? 3 or 1. So how many negative? 2 or 0. Now, this is where things get kind of funky with you. And I'm going to go ahead and I'm going to do this one for you. Chapter 2, 3, worksheet 2, number 8. So you're going to have f of x is 8x to the 5th minus 30x to the 4th minus 27x cubed plus 72x squared plus 22x minus 24. So my positive roots, this is going to be 1, 2, 3. Do we all see that? So you're going to have 3 or 1. My negative f of x, this changes, this stays, this changes, this stays, this changes, and this stays. So my negative roots are going to be same. Here's 1, here's 2. So this is going to be 2 or 0. Do we all understand the counting? Yes? This is where things get kind of crazy for you guys. We have positive roots, we have negative roots, imaginary roots, and our total roots. Our total roots has to be 5. So if I'm 3, I can pair my 3 for my positive roots with 2, or I can pair my 3 with 0. Do we all understand that? Yes or no? So 3 plus 2 gives me 5, so that leaves 0 left for imaginary. 3 plus 0 gives me 3, that leaves 2 left to be imaginary. Yes? So now we need to do the next one. 1 can be paired with 2, or 1 can be paired with 0. They both have to have a total of 5 roots, so that leaves this over here to be 2 roots, and this over here to be 4 roots for the imaginary. Do we understand that for Descartes' chart? Yes? This is usually where everybody messes up, is the chart. Do you understand the chart? Okay, that brings me to number 9. What type of roots would you have for number 9? Well, what's the number that you're going to get for number 9? 89. Is 89 a perfect square? No, so that means you're going to have 2 irrational. Do we all understand that? What number do you get for number 10? Negative 64. So what type of roots are you going to have there? Imaginary. Number 11. What number do you get there? Is 225 a perfect square? So what type of roots will you have? 2 rational. Number 12. What are you going to get there? 0. What's the square root of 0? 0. So what type of roots are we going to have? A double root. There are 4 things that you can choose from: rational, irrational, double, or imaginary. Okay? If it is equal to 0, you have to write double root. That means it's touching that number at that value on the x-axis, but it's not going through the axis over to the other quadrant. It's simply touching it and going back to the same quadrant it was in. Yes? Okay, that brings us to number 13. Somebody give me the list of P over Q values for 13 that you should have had. Who wants to do it? Jaden? Plus or minus? Correct. 1, 2, 4, 8, 16. 1/3, 2/3, 4/3, 8/3, 16/3. Do we all understand that? You did a great job. Okay. Who in here can tell me my lovely Descartes' positive roots? 3 or 1. How about my negative roots? 0. So give me one column, or I should say one row out of your Descartes. 3, 0, 0, 3. What's another row? 1, 0, 2, 3. Are there any other rows? No. Very good. Do we all understand Descartes? Now, when you graphed this, did you find all of your roots in your list? When you graphed this, did you find all of your roots in your list? What do I mean? Remember, you only have to do synthetic division at the values that are not in your P over Q list. You with me? So if I have, how many roots am I supposed to find here? 3. If I graph this function and I can find 3 roots and they are in my P over Q list, I don't have to do any synthetic division. Okay? So I'm going to pull up a graph and I'm going to show you guys, and this is going to be negative 3x cubed plus 20x squared minus 36x plus 16. So if I graph this, this is what we get, correct? Now that brings me to the next thing here. If I hit menu, analyze graph, and do 0, is 4 over 0 in my list? In my P over Q list? Yes, it was. So let's do it again. Is 2 in my P over Q list? Yes. Let's do it again. What is 0.667? What decimal is that equivalent to with the fraction? What fraction is that? Two-thirds. It's 2/3. Is 2/3 in my P over Q list? So your roots that you have, root 1 is 2, root 2 is 4, and root 3 is 2/3, or any order that you want them to be in. You with me? Do I have to do any synthetic division on that problem? Why? I found all 3 roots. They're in my P over Q list. I know that my remainder will be 0. It does me no good to do synthetic division because there's no point in it. So my factored form will be what? Correct. X minus 4, X minus 2, and X minus 2/3 is correct. Do we all understand that? Okay, number 14. Who wants to give me their P over Q list? Or would you like me to read them off slowly? Okay, are you ready? Plus or minus 1, plus or minus 3. Did we get them? Plus or minus 1/2, 3 over 2. 1/4, 3/4. 1/8, 3/8. 1/16, 3/16. 1/32, and 3/32. Why are there so many fractions? What is P in this problem? P is your constant term, which is 3. Your Q is your leading coefficient, which in this case is going to be 32. 32 has a ton of factors. The factors of 32 are going to be 1, 2, 4, 8, 16, and 32. That's why you have so many fractions. Do we all understand that? So if I wanted my viewing window, what would my viewing window be? What's the biggest number in my P over Q list? What's the biggest number in my P over Q list there? Isn't it 3? Because the rest are fractions that have a heavier denominator than they do numerator. So that has to be 3. So my viewing window is going to be from -4 to 4. Do we all get that, yes or no? Okay, the rest of the period is your guys' to finish up and do anything you want. My answer keys are up here on my podiums. It just is going to take practice. If you guys have any work for me that's done, please place it in the bins and I will grade it. If you want the weekend to make sure that you need to look over a few things and get them fixed, bring them back to me on Monday. That is fine. We are out of here at 02. Okay?